Okay, welcome everyone to Connected Data World and the highly anticipated panel on sustainability. Apologies for the late start for a few minutes. Had a few technical gremlins, including one highly unsustainable feature, which is my voice at the moment, which has sadly gone AWOL over the last couple of days. But we'll try our best to muddle through. Might be a slightly less interactive panel on my side, but we have three fantastic panelists, and we've had some great discussions leading up to the panel. So I'm sure it will be a fantastic session. In terms of format, we're planning to run for around an hour and a quarter. We're going to start off with a few minutes from myself, just kind of setting the scene on this space and kind of some of the different things that are going on. Then we'll formally introduce all of the panelists, who will all have 5 minutes each to kind of talk about their respective areas of research of interest, the projects that they're working on in this space. And then we'll move into a panel discussion on different topics. The idea is to try and keep today as interactive as possible. We have a Slido poll with a few questions for audience members to interact with, and do use the chat functionality as well to reach out with any questions as the session is going on. So I'm James Fair. I'm the CEO of Neural Alpha, a sustainable fintech consultancy, and also the co-founder of Connected Data World. So graphs and the whole connected data ecosystem and sustainability has been something that's been very close to my heart, and something that's kept me very occupied in recent years, and particularly this year, where I've taken a bit of a step back from co-organising connected data. But I'm pleased to say we've had fantastic results, and this year's conference is looking probably one of the best that's ever been hosted. So I'm really excited about the session today. So I'll start with attempting to share my screen. I can. How's that? Can everyone see that?
Yes.
Great.
Yes, we can.
Brilliant. Sounds good. Okay, so a very quick whistle-stop tour to try and set the scene on what is the intersection of connected data and sustainability. What are the interesting things going on in this space? What are the challenges? What are the opportunities? So I guess first of all, one of the things that we talked about as in the preparation sessions was actually kind of parameters on what we mean by sustainability. It's a very loaded term, tends to mean different things to different people. So I started in a place that all good seasoned researchers tend to start with, which is Wikipedia, and helpfully took some of these images, or borrowed some of these images from that. So I think sustainability as a concept has really been on this kind of journey, I guess, since the 60s, when a lot of the kind of environmental movements that we see today started. And a lot of people have credited these movements of emerging partly out of things like space exploration, where we were able to see the Earth as this kind of fragile kind of ecosystem, this part of the universe. So really kind of like moving on from the 60s, people started to try and put definitions around what sustainability is. And I guess one of the kind of most famous definitions is really that from Brundtland in 1987, in the famous Brundtland report, where there was an attempt to define sustainability as meeting the needs of the present generation without compromising the ability of future generations to meet their needs. And that seems to be a definition that's kind of stuck with us for several decades now, albeit something that has evolved to encompass concepts wider than just the environment. So you've started to see things like a definition of wider concepts, things like ESG, environment, social governance, economy, and things like sustainable development goals, also kind of touching on more of the human aspects of sustainability. And then arguably that, you know, obviously one of the things that's dominated sustainability has obviously been carbon and decarbonisation and climate change. But I guess it's probably important to note that it's not the only environmental consideration. You know, coming just out of COP26 at Glasgow, arguably nature was the bigger topic that got a lot more focus than decarbonisation. You know, talking about things like the biodiversity crisis, nature depletion, ecosystem services dependencies. A lot of that stuff was gaining a lot more precedence. And we see this being talked about time and time again with things like planetary boundaries and other concepts. So in terms of the role that connected data plays, we see, you know, unusually this is not a new area for connected data. Arguably, some would suggest that it's actually where connected data started. There's a very famous thing, which I think many people are familiar with, the Linnaean taxonomy, pioneered by Carolus Linnaeus in 1751. Now, Linnaeus is generally considered to be the father of modern taxonomies, you know, taxonomies being a key backbone of modern computational approaches for things like knowledge graphs, semantic search, and other things within our ecosystem. So so arguably we got off to a, you know, fantastic start. Moving on though, you know, where are these things moving today? What are the exciting things that are going on in this space? Well, I think sustainability is, you know, one of these really exciting features, really, or one of these really exciting domains that things like open source knowledge graphs, such as DBPedia, Wikidata, and many others, you know, it's a really exciting topic. It's broad enough, it's semantically complex enough to be a fantastic use case for these platforms to tackle. So it was actually something that I tried to do when preparing for this session, really, is kind of eating your own dog food and trying to use these tools within the connected data ecosystem as a bit of a recap. And, you know, I think it took me pretty much all of 5 minutes to go and download the fragment from DBPedia on sustainability, which is of course derived from Wikipedia. It's scraped from Wikipedia using NLP techniques. And it took me about 5 minutes to load this N triples fragment into a triple store, and then just start to visualize some of the concepts. This saved me a hell of a lot of time in terms of, you know, making annotations, making notes. Yeah, really served as a fantastic memory aid or mind map, if you like, of you know, what we're here talking about today. And really, this is what connected data is all about. Is you know, accelerating these very natural ways that the human brain thinks. So finally, in terms of I guess a brief assessment of things that are going on in this space. Now, this is by no means a comprehensive assessment of the different activities that are going on, different projects within the connected data space, but hopefully gives you a bit of a flavour of some of the variety of things that are going on. So outside of open source knowledge graphs, there are a number of analytical platforms that are being developed, particularly to tackle things like supply chain transparency. This is something that we'll hear from our panelist, Tanya, about today with some of her work on trace finance. We've also seen there's a lot of activities happening around ontologies and taxonomies. So a number of different taxonomies in this space, you know, ranging from very, very small taxonomies focused around the SDGs to, you know, truly mammoth taxonomies, things like AgriVoc, which I think has kind of hundreds of thousands of concepts at last counts. And then you've got other really exciting kind of platforms that are blending some of these different things, mixing them with NLP, mixing them with semantic search, with knowledge exchange tools, things like climate tagger, renewables tagger, and then broader platforms such as Blackard and We Adapt, which are looking more at things like climate resilience, for example, adaptation strategies. And then there's also a lot of really exciting things around things like the role of AI and fake news, which we'll also hear from Abhishek, one of our panelists today from. So without further ado, it's my great pleasure to formally introduce our panelists. We have three fantastic panelists today, including Paraskevi-Zerva, who's a long-term friend of Connected Data, has been involved with the conference for a number of years and is the senior data and applied scientist at Microsoft. Sorry, just a second, I've just closed the screen share. Sorry, I've got a bit of a technical problem on my screen saying that content's locked. Sorry, that's better. So Paraskevi is part of the observability team at Microsoft 365. Also very, very passionate about data modeling, data architecture, lots of experience in the linked data space, particularly with RDF and related areas. We also have Abhishek Gupta, who's the founder and principal researcher at the Montreal AI Ethics Institute, who are an international non-profit research institute with a mission to democratize AI ethics literacy. He also works in machine learning and serves on the CSE Responsible AI board at Microsoft, and is helping them to tackle some of the largest technical challenges with Microsoft's biggest customers. And finally, we also have Tanya Beck, who is a data engineer working with myself at Neural Alpha, particularly focused on the trace finance platform, which is all about linking or understanding how financial institutions are exposed to deforestation. So now we'll move into the presentations. I think first up we have Paraskevi, who will be giving a 5-minute introduction to some of the sustainability work and projects that she's been involved in.
Hi everyone, and I hope I keep it short, James. So would you be able to share then my slides, or should I share on my side?
Yeah, I can do that. How's that? Can you see that full screen?
Yep. Okay. So can I move around the slides, or you have to do this for me, I guess?
I think I have to do the steering.
Okay. Yeah. So, hi everyone. It's really lovely to be able to be here today discussing about sustainability and connected data. As James mentioned, I'm a senior data and applied scientist at Microsoft. I work as part of the M365 People Experiences Observability team. Well, I'm also a member of the sustainability community and the Green Software Foundation, of which Microsoft is a steering member. And also I'm doing research on the space of international marine sciences with Heriot-Watt University. So this includes environmental sustainability topics, marine conservation and climate change. And my background is classic computer science, and I have been working for around 10 years on data architecture and issues with data governance and data quality and connected data, ontology, modeling, and knowledge graphs. And then I moved to the space of data science and AI and ML. And the last 3 years, I'm looking into how to use AI and ML for basically contributing to the sustainability problems. So yeah, if you can move to the next slide, James. And the next one, so the challenges, I would say I have been observing while working on this space. It's been, first of all, sustainability itself as a concept is a multifaceted definition. So this varies along like with the different domains and sectors. And there is certainly a need for taking a modularized approach to model the sustainability domain. So there are some efforts on having a common sustainability like kind of meta model on top, but then there is not much maturity on interconnected ontologies describing sustainability at more granular level in the different specific domains. While another gap I'm observing while working in this space is the lack of like maturity on the how to define sustainability metrics, or having a domain-specific language for that to measure basically sustainability about different processes in an organization, the infrastructure, the software, the applications. And then if we move to the data space itself, we can see that environmental impact assessments require a lot of environmental monitoring data to be provided with good quality in standardized formats and to be easily interconnected, so we can analyze this, so we can provide regulatory reporting for environmental policies, for example. So certainly there is a need for data governance techniques on this space. And then some more challenges are around the computing resources themselves. So the infrastructure, the storage and processing technical resources and needs for these for analyzing environmental data is a lot of the times of like petabyte scale. And maybe a last thing I would like to mention with regards to challenges is the decarbonization strategies. So we can see in organization there are more or less 3 patterns for decarbonizing. So electrification, carbon storage, and renewables. Yet there is a lack of consistency on the way organizations report data about these strategies and choices. And there is a challenge in sharing data and exchanging this knowledge in this space. So certainly like connected data can contribute on that space. Yeah, maybe in the next slide. So yeah, I would give you just a very brief reference to some of the projects we've been working. So the first one is about using deep learning for marine conservation for killer whales in the Canadian Arctic and the South Sea. So this has been a collaboration with the University of Victoria, Canada, and the Canadian Wildlife Services and Heriot-Watt University on analyzing and understanding the vessel noise impact to cetaceans like killer whales by analyzing hydroacoustic data and using AI techniques such as deep learning for analyzing time series data and also computer vision techniques for image processing. So we can see already for trying to resolve this kind of sustainability issue around biodiversity and the impact to biodiversity, we have to connect a lot of different data, and we need to consider a lot of different ways to process this data. Yeah, and the second project, we move to the next one, is about coral reef bleaching events and monitoring this using machine learning. The University of Queensland the Queensland University of Technology in Australia has received the Microsoft's Azure grant to basically improve their technology and research on collecting data regarding the health of coral reefs in Queensland, in Australia. And this is about using drone technology and hyperspectral cameras to collect data and then creating a bleaching detection model in order to analyze the health of the coral reefs. And then if we move to some more general projects along in Microsoft, so there is the AI for Earth, and I would like to mention the planetary computer. That's an initiative that Microsoft AI for Earth works on creating a petabyte catalog of global environmental data and a set of APIs, and this can be used by researchers and the scientific community, but also other organizations working in conservation to support sustainability decision making. And if we move to the next slide, we can see the main components: data catalog, APIs, hub, and applications. And I would say the data catalog is the main concept here, connected to the like the connected data concepts and ontologies. And last, if we move, James, to one more, the Green Software Foundation. So this is a foundation where, as I mentioned, Microsoft is a steering member. It started with a focus to build a drastic ecosystem of people standards tooling and best practices for green software. And if you move to the next slide, here is just a list of steering members. And if you move to the next slide, we can see there are a number of working groups there. I've been involved in the standards and innovation group. And then if you move to the next slide, I have a list of some current projects this community has been working on, such as the Awesome Green Software. So this is about creating a list of tools and best practices for building applications that emit less carbon and are carbon aware. So this is more like an introduction to people that want to work on this space. And then we have other projects such as the software carbon intensity open data and carbon intensity specification. So this is about specifying a methodology to calculate the rate of carbon emissions for a software system. And the last one is about the carbon aware SDK. So this is an SDK to enable the creation of carbon aware applications. And yeah, with that, back to you, James.
Cool. You've said it for me, Paraskevi, but thank you. It's already a fantastic, amazing introduction to a hugely varied amount of work. So I think we're on to Abhishek now, if that's okay, Abhishek. If I can
absolutely.
try and find, I have got the link here. Let me just bring that up. Okay, I've not used Canva before, so you might need to...
Well, if you just hit the full screen at the bottom.
There we go.
And then you just use the arrow keys to navigate. So
great.
That should do the trick. All right, well, Hey, everybody. Great to be here at Connected Data World. And thank you to James for the introduction in the beginning. And it's I think, a very important topic that we're going to be talking about today. Just to give you a peek into one slice of the work that I do amongst several others, which is on the imperative for sustainable AI systems. So just as a quick sort of extension on who I am and what I do, the founder and principal researcher at the Montreal AI Ethics Institute. It's an international nonprofit research institute with a mission to democratize AI ethics literacy. So we spend quite a bit of time working on assessing the societal implications of AI systems, amongst them the sustainability implications, which is what I'm going to sort of briefly mention over the next few minutes. And of course, the work that we do at the Institute spans applied technical and policy measures. We have a heavy bias towards action when it comes to addressing the societal impacts of AI. I also do machine learning at Microsoft. I work in what's called commercial software engineering, where we hope to solve some of the toughest technical challenges for Microsoft's biggest customers. And finally, I'm the chair for the standards working group at the Green Software Foundation. I lead the work on the software carbon intensity specification, whose alpha version was just released a couple of weeks ago. And as Paraskevi had mentioned earlier, it's a methodology to help people make assessments about the carbon emissions that emerge from software systems and how to go about sort of quantifying them and working towards improving them. Next slide. So AI systems have an environmental impact, and this is not about how AI can help address climate change, which it can. There's a lot of great work that's happening in that space, and it is an important discussion, but more so what I'm going to touch upon right now is that the fact that we have that we design, develop, and deploy AI systems, they leave an environmental footprint, and that footprint can actually be quite large. Why? Because AI systems are quite compute intensive, and there are sort of various associated aspects, both on the software and the hardware level, that lead to its environmental impact. Next slide. So the imperative for sustainable AI systems is in particular, if you Google this title, you'll find a research article that I published recently that was the winner of the inaugural Gradient Prize, diving deep into why it is important to consider sustainability as a core function of the design, development, and deployment of AI systems. In addition, it's also the culmination of more than 2 years worth of work going in assessing and figuring out how we can build more sustainable AI systems. And primarily the argument there is that it has not only AI systems not only have environmental implications, but they also have societal implications, and both of those are intertwined. And it's important that we when we're designing, developing, and deploying these AI systems, we elevate the sustainability considerations at the same level as our big business and functional needs that we seek to achieve with these AI systems. Next slide. So I'll quickly touch upon just a few challenges with the current paradigm, what sustainable AI is, and what we can do next. Next slide. So the challenges with the current paradigm are threefold. So the first is if we look at the state of AI systems today, we continue to inch towards using larger and larger models. State of the art is heavily focused on pushing that boundary further so that we build ever larger systems. And what that naturally entails, at least in the current dominant paradigm of supervised machine learning, is requiring larger and larger data sets, which promotes exploitative data practices. So all the debate and discussion that you see around today when we talk about, well, what is all the extractive data practices that take place in terms of privacy, in terms of invading and manipulating our behavior so that we can gather more data to feed these systems. That in part is a linking factor with the current paradigm. It also leads to centralization of power. What I mean by that is if you have larger and larger systems, there are only a few very well-funded organizations, corporations, research labs that are able to build and operate these systems. And that also naturally leads to homogenization in the sense that there is only a small crop of ideas that can be manifested into the world, because there are only a few people, a handful of people, or a handful of organizations who are able to realize and create these systems in the first place. So it really goes against the grain of us trying to democratize these abilities, because there's only a small set of people who are able to really operate at that bleeding edge. And finally, when we're looking at such large systems, they have a tremendous energy footprint, both in terms of the embodied carbon emissions when it comes to the scale of these systems, but also in terms of just the raw energy consumption to operate these systems. Next slide. So what is sustainable AI? Sustainable AI is this idea of building systems that are cognizant of their environmental footprint. And what that means is elevating some of these smaller models. When you think about notions like TinyML, or thinking about techniques like network distillation, network compression, all of these ideas that elevate smaller models to achieve similar performance. That is sort of one pillar for sustainable AI. Also thinking about alternate deployment strategies in terms of techniques like federated learning. If you can offload training and inference to edge devices, so that if they are operating in a less carbon intense location, you can profit from sort of greener energy consumption as a part of your AI lifecycle. And finally, designing and developing and deploying these systems in a carbon efficient and carbon aware fashion is another way to build sustainable AI systems and manage their environmental footprint. Next slide. So what can you do next? And of course, we've got the rest of the panel to talk about a lot of these issues, and if folks have questions, I'll be happy to answer them in the chat as well. But start to share the idea of sustainable AI more widely. It's still not something that is seen as an equal or a peer to business and functional considerations, and so elevating that up to the same level is very important. Instrumenting your AI system so that you can gather this energy-related telemetry is another important step. And finally, as I said, right at the beginning as well, making carbon impacts a core consideration at the same level as business and functional requirements is going to be very, very important if we are to succeed in this. Next slide. And that's me. You can I'm fairly active on Twitter, so you can reach out to me there or via email. I also write a weekly AI ethics newsletter that's read by about 6,000 technical and policy-making leaders in the domain of AI ethics. In case you're interested in getting the latest in research and reporting there, I invite you to follow that as well. But yeah, over to you, James.
Right, thanks, Abhishek. It's really, really fascinating, thought-provoking talk, and yeah, I definitely encourage people to have a look at the AI ethics position papers. I had a read through a couple of them on defense and other things that had not even crossed my mind, and it was really, really fascinating reading. So with that, we now have our final panelist presentation from Tanya Beck on trace finance, and then we will move to polls and Q&A.
Yeah.
Take it away, Tanya.
Thank you. Hi, everyone. Thank you so much for having me on this panel. I'm Tanya. I will be talking about trace finance, which is a great example of how you can use connected data to solve sustainability problems. And I'll be talking for the next 5 minutes or so. So let me start by briefly introducing myself. So if we go to the next slide, I have a background in environmental economics, and I've also worked in corporate social responsibility in the NGO sector, always in data-centric positions. I've also done some research which kind of links to the theme of this panel. So for example, I've previously collected data on Monsanto presence in states and linked it to pesticide use, specifically glyphosate and mortality in the US using econometric analysis. I've focused on green IT through the lens of calculating the carbon footprint of an advertising campaign. And I've also used natural language processing to do topic modeling on reports published by big tech companies. And this was to explore the environmental impacts of the tech sector, specifically their influence on policy and renewable energy adoption. So I've always been interested in the nexus of sustainability and data, and particularly leveraging advanced technologies to answer complex sustainability questions. And trace finance is a great example of that. So what exactly is trace finance? If we go to the next slide, so trace finance is essentially trying to answer one seemingly simple question. The question is, how are investors and lenders exposed to deforestation risk, and to what extent? And this seems like a very simple question, but it's actually has a highly complex answer. So there are cases in which financial institutions will have highly concentrated credit and equity risk in a small number of direct holdings, which are then easy to understand. But for the most part, we see obscure global supply chains and complex ownership structures. So in order to understand all of this, on the next slide, essentially trace finance leverages connected data in order to provide insights on deforestation risk in financial markets. And what I'm going to do in the next few minutes is just break down slightly the platform and some of the data sources that we amalgamate in order to provide these insights. And I think, this demonstrates the power of connected data. So the first layer that we have, which is on the next slide, is essentially a physical commodity supply chain. And this already requires an immense amount of expertise in international trade, as well as an understanding of deforestation on the ground in order to produce this data. So essentially it's connecting consumer markets and trading companies to sourcing regions, and as well as then the deforestation associated with it. On top of that, if we go to the next slide, trace finance is then mapping capital flows into these traders and essentially connecting the financial data to these lenders. And this can go through a number of different pathways. So we have pathways such as legal entity ownership structure, project financing, joint ventures, corporate bonds and equities, etc., etc. So in order to this is just a very sort of basic breakdown of how it sort of works. And in order to give you an example of just how this complexity can look, I'm gonna talk about just one example that only scratches the surface. So on the next slide, you will see that there, So here we'll be talking about Piauí, which is a state in Brazil. So in 2018, Piauí was estimated to have about 5,000 hectares of deforestation due to soy conversion. And Piauí is actually part of Mato Piba, which is a region with many high-risk commodity traders operating. So out of this 5,000 hectares of soy deforestation, 70% are linked to 11 commodity traders. And these 11 commodity traders are then linked to an average of 2 importers, which sit in China, Japan, Saudi Arabia, Thailand, Germany, etc., etc. And so up to this point, we sort of have, it's already quite complicated, but relatively simple. But some of the intense complexity arrives at this stage where the scope broadens, and we actually, knowing that these traders are either publicly listed or issue debt listed instruments, we will have 5,500 equity investors exposed to these traders through around about 4,000 funds. And this is just one type of risk. So we also have the possibility of reputational risk. In this case, 1,600 investors exposed to this risk by having bank holdings, 67 banks for Piaui, which are lending to these traders. So this is just one example. We're only scratching the surface. We're only looking at one commodity, which is soy. Piaui, which is one of 28 states in Brazil. Brazil in 2018 was estimated to have 61,000 hectares of deforestation. And just with this one example, I think you can already see the extent to which this can be a highly complex issue to solve. But I hope you can also see to what extent connected data can help us model this reality. So trace finance essentially offers financial institutions the possibility to do this due diligence on their supply chains and understand the risks they're exposed to. And if you go to the next slide, financial institutions, by that we mean, asset owners, asset managers, banks, financial service providers, so a whole range of actors in the financial markets. But this data can also be used by researchers, by institutions that are, creating policies, or the NGO sector. And essentially, just to conclude on the next slide, trace finance is trace finance is a graph-powered open data platform for understanding how the financial industry is exposed to and contributing to deforestation. Personally, having worked on this for the past 6 months, it's not something I came up with, but I think the power of this idea is not only that it leverages advanced technologies such as connected data in order to provide a real understanding of a complex sustainability issue, but also that it essentially provides a real solution to a real problem, which is financial actors needing to do due diligence on their supply chains and facing highly obscure supply chains and ownership structures. So I think it's a great example of how connected data is helping us solve sustainability problems, essentially. And that was sort of a whistle-stop tour of what trace finance is and what it can do. And then just this final slide, you'll find some information on where to find Neural Alpha, which is the company that I work with. And incidentally, if any of this has piqued your interest, we are hiring. So any data scientists, any data engineers, I can attest to the fact that it's an extremely interesting project to work on a daily basis. So yeah, that was just a whistle-stop tour. Please feel free to ask me any questions, and I apologize for not being able to turn on my camera. Thank you so much.
Great, thanks a lot, Tanya. That's really fascinating to hear about, and 3 very diverse use cases, applications of connected data to sustainability. So with that, I will ask the other panelists who have not had explosions and other various cataclysms going on, perhaps to turn back on cameras, if that's okay. And we will have a look and see what is going on with our poll. So we asked how many people in attendance are working with connected data on sustainability challenges on a day-to-day basis. and the majority are, which is a great start, good place to be in. Hopefully some of the no's, it's something that will increase over time. We have a couple more slides as well, which we'll also run through. Sorry, a couple more polls, which we'll also run through as we get the conversation going. Great. So maybe to kick off, I guess one of the things that was really fascinating from the discussions leading to the panel was this concept of the actual green credentials of the software that we use to build these solutions every day, being something that's being thought about by people like the Green Software Foundation. So I think the $1,000,000 question that everyone's asking in personal consumption habits is, how can they become more sustainable? Things like beef having a huge carbon impact, deforestation impact, compared to things like chicken, which have are a lot more sustainable. So I guess one of the questions that we're all curious about, and perhaps Abhishek has the answer, or maybe it's a work in progress, is which programming frameworks are more sustainable than others? Is Python the beef of the computer programming world? Should we be ditching it from our day-to-day toolkit to become more sustainable practitioners?
Well, that's one way to stoke a fire there, James. I think, given that Python is the darling of the data world, and I'm an ardent Python user myself. So it's difficult to veer away from it, given how fundamental and foundational it has become to all our practices. Though when you look at it purely from the environmental side of things, it does actually end up, as you said, end up as the beef of the programming world. Though I'll caveat that by saying that a lot of that can be mitigated if you are more carbon efficient, more hardware efficient, sorry, I should say more energy efficient, more hardware efficient, and carbon aware in the design of the systems. As you're utilizing, Python or any other programming language for that matter. I mean, if you look at the environmental footprint for similar code in C, what you do see is, perhaps close to an order of magnitude in terms of a reduction in the environmental footprint. But that doesn't, take away from your responsibility when it comes to designing the system to be energy efficient, hardware efficient, and carbon aware in the first place. Why I say that is, you can, again, if I, go back to the work that we've been doing on the AI front on this, it's the way to think about it is, if you've trained and built a system once and it's expected to be in operation for a long time, what would amount to a larger slice or a larger share of the carbon footprint would be the inferences that are run from that system. So, thinking on how you can optimize for the inferences, be that, choosing optimal hardware, serving up the models in an energy efficient fashion, running batched inferences so that you can, profit from lower carbon intensity energy. All of those things will also have a big impact. So, long-winded answer to your question, James. Yes, Python can be inefficient, but I wouldn't lay it at the feet of the programming language. In fact, I would urge people listening to, be active agents. We do have a lot of control in our hands, and so being smarter about our design can allow us to use our first love, if that's the case for you. At least it is for me with Python. At the same time, being environmentally conscious as well.
That's great. Thanks, Abhishek. It's a good way of making us all feel a bit better about some of our individual choices. So I guess moving on to a slightly wider question, I guess we've heard from three practitioners that are working with connected data day to day, very, very different use cases on sustainability. I wondered whether you had any thoughts around which use cases within the sustainability space are perhaps more suited to connected data technologies versus others which are less suited, perhaps more suited to the conventional normal data space, so to speak, the kind of big data side of the world. I don't know who to start with that. Perhaps Paraskevi. I think you've been in this space a long time and been involved in many different types of projects. Perhaps we could start with your thoughts.
Yeah. So yeah, certainly. I feel there are different patterns with regards to the different problems we have to solve sustainability in the different spaces. I would say that naturally there are some spaces such as resolving issues with regulatory requirements for environmental policies that require data governance, which is a mature topic within connected data space already. So I think naturally that's a topic that where connected data fits as a solution. And then there are possibly more I would say more suited problems regarding the complexity of the data we need to structure and model or analyze in order to get answers to questions for sustainability problems, such as, for example, the product supply chains. I think Tanya also mentioned this as an example where you need to trace back and connect data at different stages and of different processes in these workflows. And of course, there is the problem of sharing knowledge and sharing environmental data to basically perform these environmental impact assessments. So it's a problem of data exchange, basically. Yeah, so these are a few I can think on top of my mind.
So would you say, do you think that connected data is more geared towards in this space things like knowledge exchange, data integration projects, essentially, I guess the hard work, if you like, to make the data available to expert practitioners, or is there an equal role for connected data to play in the actual analysis of the data, graph algorithms, the machine learning aspects, that side of the world?
Yeah, I think it's both. Maybe in terms of what's the first problem we need to solve when we are looking into the sustainability space and how we can use connected data to resolve the challenges there, is to provide standardization around the definitions in the sustainability space, provide tools for data governance, and also provide the means to create language for standardizing sustainability metrics in the space, so we're able to measure sustainability in the different domains. And then, of course, it's also about how we could best model and connect and structure this data as input features to machine learning models that could then be used for resolving challenges and sustainability problems in the environment space.
Cool. That's really interesting. Any comments to add to that from Abhishek or Tanya? I had I had perhaps a question for you, Tanya, because I guess you know, knowing you very well personally, with us working together pretty much every day. Obviously, trace finance has been the first experience for you personally of really getting into graphs, but you've worked in the sustainability space for a while using more conventional computational approaches and databases. So I wondered, I guess, what have been some of the things that you've seen that are real advantages in working with things like label property graphs. I know you're working with day-to-day.
Yeah, yeah, thank you. Yeah, exactly. So I've been definitely in the sustainability space and seeing applications of how you can use technology and data to solve these sustainability issues and different ones. So I think, going through my past experiences, I would say, first of all, that there's a lack of maturity in the field, which I was going to actually add to what Paraskivi was saying. Essentially, when I was working in corporate social responsibility, there had been a lot of advances made on measuring your carbon footprint, but they were only dating 5 years back and getting better every year. When I was in academia and looking at, applying advanced machine learning techniques to sustainability, I was amongst the few students in the class attempting that. So I think the biggest problem in sustainability and data is maturity. And of course, there's very interesting projects that you can do where you're linking essentially modeling nature, which is almost impossible to do using artificial intelligence, or linking pollution to grades, students' grades, and when they take exams, or linking house prices to nature using hedonic pricing methods and things like that. But essentially, all of those things are experimental, and I think what sets connected data apart, and the way that trace finance applies it, and specifically because that's the one I have the most experience with, is that connected data kind of provides real world data versus in the sense that you can see real outcomes, you can see true, essentially a picture of truth, a picture of modeling a complexity, which is at a level where you're actually producing a reality in a sense, compared to doing experimental things. So I think that's what sets, for me, something like trace finance and connected data apart, is that the data that you put is essentially immediately usable, and that you output is essentially in a format that can be used by, for example, financial markets. Whereas a lot of the data that you will create through research, and a lot of exciting things that are happening in other sectors of sustainability, at this point in time, we can only say that it's the beginning. Whereas connected data, already in the beginning, we can already see some results.
Cool. Yeah, some really, really great points there. I mean, I guess connected data and graphs, it's fundamentally about structuring data in a way that we think about things as human beings, rather than going through this kind of monstrosity process of turning it into something like a relational model, or perhaps even something worse. It's probably nothing worse these days, actually. Yeah, it's really, really interesting. Thanks, Tanya. Guess I had a question for Abhishek around the application of knowledge graphs to things like disinformation, fake news. Because I guess one of the most exciting areas that we're seeing the use of knowledge graphs at the moment is in terms of things like fact checking, verifying claims, trying to verify identities. And obviously it's a huge ethical question in terms of the role that bots and misinformation plays in elections and other significant things in everyday life. So I just wondered whether you had many thoughts on, is sadly disinformation and fact checking, one of the real kind of golden use cases for knowledge graphs, and knowledge graphs fused with AI and machine learning, in your opinion?
Yeah, and there are quite a few organizations that are trying to deploy these and other techniques to curb the spread of mal, and disinformation. In fact, all of those things actually manifest quite differently when we talk about what's broadly called problematic information, because the characterization of dis, and malinformation is actually quite different, and how we apply, knowledge graphs amongst other techniques uh, has different implications when it comes to curbing the spread, and perhaps catching and flagging that content, taking it down before it even uh, gets onto the network in the first place. That said, when we're thinking about how this manifests and how it spreads, there are actually a lot of different pieces along that chain from when that content is actually created, it's uploaded, and from there on how it is shared, to what extent it gets amplified, and breaking them down into these different, let's say, atomic parts, is something that can help to solve this problem. So the one thing that I guess I want to emphasize here is that you can't apply any of these techniques like knowledge graphs or other AI-based techniques that people are uh, utilizing to solve this issue end to end on this problem of disinformation, because there are many different pieces to that problem, including things like verifying the authenticity of a particular piece of content, whether it's something that is, let's say, gaining in virality, something that is let's say a deep fake, or any of the other sort of ways that this sort of information manifests. The other thing that's particularly challenging in this space, that I think requires a lot more thought, is there are some things that are easy to verify from a fact perspective. There are others that are, uh, let's say, problematic opinions, uh, which are in the gray zone when it comes to, are they things that are rooted in facts, or are they rooted in opinions, and how do we curb their spread so that they don't cause harm? And we've seen a lot of that happen, where the spread of some of this problematic online information actually leads to real world or offline harms, as we've seen in places like Myanmar, to give one example. Uh, and finally, I think one of the biggest challenges that the field also faces at the moment is multimodal um, problematic information. So things where individually pieces of text are perhaps innocuous, or images perhaps that are innocuous, but when combined to create a meme, uh, actually are something that can constitute hate speech, as an example. And so to see some of the latest work on that, there is this challenge that was run earlier, late last year, earlier this year, called the Deepfake Detection Challenge by Facebook or now Meta, but at the time it was Facebook, and Partnership on AI that tried to address these problems. So yeah, there's quite a bit of work that needs to be done there, and I think breaking it down into very atomic chunks as to the different parts of that life cycle, let's say, of problematic information is the way to go.
Wow, that's fascinating. I had no idea that there were different ways of categorizing different types of falsities, falsehoods, alternative facts, I guess some people might call them. So taking a quick break, going back to our poll. Our polls are still running. The second poll question was, which projects do you most admire in the connected data space for sustainability applications? There's still a chance to throw a quick answer in there if anyone's typing at the moment. otherwise, I guess we were hoping to kind of crowdsource some really interesting projects from this, but I guess the lack of answers is possibly indicative of what a nascent space we're all working in. Planethon seems to be one of the main answers. So an interesting project. I'm not familiar with that, but it's something that we can have a look at. And the other projects are all mentioned by the panelists already.
Sorry, James. There's a few interesting ones in the chat actually posted by participants.
Yes, yeah, I did see those. Yeah, fantastic. Cool. So we'll spin up our third poll in a moment. We still have time for audience questions. If there's any coming through, just post them in the chat box. So we've got one question from Ed Wright. Has anyone heard of people tracking emissions across supply chains to calculate Scope 2 and Scope 3 emissions? This sounds like a question for you, Tanya, if I can put you on the spot, or if not, I'm happy to field it, or someone else can.
Yeah, sure. So actually, I think at the stage at which reporting currently stands, this is probably like the best, most high performing in terms of sustainability companies that can do this. I think probably this doesn't actually exist. I know that, for example, CDP actually calculates this using something called a bottom-up model. So I do know as well that, you know, as you go from Scope 1 to Scope 3, your uncertainty goes through the roof in terms of calculating those numbers. So I think there's obviously work being done on this. People are tending towards this. It's already been complicated enough to arrive at a relatively certain Scope 1 estimation. You know, there are definitely companies that are interested in tracking this across supply chains, but we are far from it, and they've only, you know, just, I think, started thinking about it, is the impression that I have from my experience.
I don't know if you had a comment on that, Paraskevi, or
actually, since I saw that Katerina has joined us from IKEA, like I would have a question back to her, because I have heard that IKEA has more maturity on tracking like the supply chain process, like if they have any developments on this space. If I can pose a question back to the audience.
Well, we'll give Katerina a chance to decide whether to put something into the chat, perhaps. Maybe I can add some comments in the meantime, just whilst we're waiting. I mean, I guess one thing is measurement methodologies in this space, but it's a bit of a circular reference, chicken and egg thing around also disclosures. And I guess disclosure frameworks for companies are quite rapidly evolving. So it's still, you know, relatively early days for things like TCFD, climate disclosures, which companies are, you know, starting to integrate into their annual reporting cycles. There's also a lot of activities happening from people like GRI and other initiatives. But I think every it's kind of the holy grail, I guess, Scope 2, Scope 3, particularly Scope 3 emissions. So yeah, I think it's I think a lot's going to happen there in the next 5 years.
Well, and also, James, if I may add, you know, the purpose of tracking any of these emissions, you know, I think what needs to be front and center is an understanding of whether, what is the end goal of tracking these emissions, right? If it's to trigger behavior change, which I hope that is the goal, to what extent is accurate tracking of that actually enabling that to take place, right? The reason I bring this up is a lot of times we continue to stress on you gathering more data and makes sense. We're at the Connected Data World Conference. We talk about gathering and utilizing data. But if gathering more data isn't leading to behavioral change, what is the point? The reason I bring this up is, again, if with the data that we have, if we can better utilize that already to design interventions and be smarter about triggering that behavior change, maybe we don't even need to twist ourselves into weird contortions to gather these scope 2, scope 3 emissions, because they are incredibly difficult to calculate and trace back. If with existing data we can design better interventions through the supply chain and at the end ask consumers or get consumers to make better choices, that to me is a bigger win than trying to barrel down a path where we're investing all this energy in gathering this data without actually having this end goal in our mind, which is, well, is it triggering behavior change or not?
If I can just sort of say a point to that, I definitely agree with everything you're saying, because as we get better at measuring things, we're only measuring things that are continually going up. So there's not necessarily a point in measuring things just to understand that we're not changing. But I do think what's really interesting is, I think at this point in time, calculating something like any kind of financial data or a lot of different types of data in this world, which probably didn't have this maturity to start with, are now sort of an everyday routine type of thing. And I think it would be really interesting to get to a point where we have such an in-depth understanding of a lot of sustainability data. I mean, I definitely agree with what you're saying in general and in principle, but I definitely think that the more we can measure in terms of, just getting into a place where it's routine to know the state of marine life, to know the state of nature, and having it in numbers, I think that will help potentially. But yeah, agreed that behavioral change has to be the focus, and we might be out of time.
We're almost out of time, but we've probably got a few more minutes to just wrap up. We've had Katerina join us, and yeah, really, really great point that you made there, Tanya. I mean, it was one of the points that came out of COP, for example, on nature and biodiversity, is there is no equivalent measurement barometer to what we have with carbon. We have degrees of warming and parts per million for measuring things like biodiversity. There are many different measurement standards, for example. So I'm pleased to say we've had Katerina join us as part of the great kind of interactivity that we have on these panels. I'm not sure whether, Katerina, you'd like to share a few thoughts on the question posed by Paraskevi. Looks like you're on mute. Okay. Yep. Welcome, Katerina.
Hi.
Hey.
Yes.
Good to see you again.
Yeah, nice to see all of you again at these conferences, and I'm sure in the next few days we'll be seeing more of each other as we progress. So about the question in itself, I mean, what needs to be said is IKEA is at the beginning of its knowledge graph work. I'm one of the first hires 3 months ago. I was hired to IKEA to build that knowledge graph capability, and so it's really about setting the team up and hiring more people currently. But surely we do also our knowledge graph work in itself, and we have organized it in such a way that the fourth part of it is sustainability. Now, I cannot say more about what it's going to be because I don't even know that yet. But for IKEA, sustainability is a top priority, as it is for many other companies as well. There's some commitments IKEA's already made to be free of plastic or to be using sustainable materials more and more, or even fully to some extent. And all of that will need knowledge graphs. What I can say from e-commerce in general having done that with knowledge graphs before, is that already if you look at that e-commerce space, selling to customers, just giving them the right kind of information on product sustainability is already does quite a lot, so that they can choose to buy more sustainable products. Obviously, then buying is one part of the problem of sustainability, that needs to be acknowledged at the same way. But in case of that kind of mechanics hopefully promotes this kind of consumer behavior that then hopefully also gets more and more companies to introduce ideas of any kind of ESG from the ESG space, especially circular economy. So I'm sorry, I would want to be more specific, but my team's not even that specific yet. But if there's anything else, I'm happy to answer more.
Wow, thanks so much, Katarina. It was amazing to hear. Just impromptu joining, and yeah, best of luck with the journey. I can imagine it will be a huge challenge. I mean, IKEA are certainly one of the more sustainable companies out there in that space, but I'm sure it's a huge effort ahead in terms of understanding the supply chain and different policies and all the other kind of wonderful facets of the sustainability space. So I think with that, we're pretty much out of time, but I would encourage people to reach out, get in touch with the panelists if you have any follow-up questions on myself, and we'd be more than happy to catch up after the panel. And yeah, round of applause for our wonderful panelists, and also such a fantastic interactive audience. So thank you very much, and have a great afternoon or morning, depending on where you are.
Thanks everyone for joining. Thank you and bye.
Bye.